Okay, welcome to this course on advanced analytics in healthcare, SQL, generative AI prompting for good SQL. We are in this crazy new environment where SQL is much more accessible. Healthcare data is continuing to grow, and so the ability to access it and use it is more and more important. Generative AI is this phenomenal opportunity where the technical barriers to get at this continue to become smaller and smaller. But it means that human review is going to be necessary to ensure we've got some accuracy in preventing the misapplication of SQL. This is something that you can do. Don't be discouraged by this. Don't listen to the naysayers or the people who already code in SQL that will tell you, oh no, now everybody thinks they can do SQL and they can't ensure they're doing it right. The future will belong to the thinkers. If you're able to think through what you're doing, you will be able to use these tools to be able to accomplish SQL. The people who write SQL without thinking about the problem they're solving still are going to be in trouble. But if you will dedicate yourself to thinking through the problem with this new tool, you can do this, and the barriers are lower than ever. So here is the workflow we will be going through. Prompt, review, and validate. Very, very simple, very straightforward. Step one is prompt. Here's the most basic example, but we're going to go through in detail a lot more about this. Number one, injecting the information about what database you are looking at. For me, I've got a JSON file written about the database, and I'll share it within my course on the dataset that is on BigQuery. It's a structured file that shares every table, the description of the table, and every column and a description of the column. This, for me, on anything that I'm going to routinely use to write SQL against, I get this structured file in place so that whenever I've got a question in order to build a SQL query, I go ahead and just upload this file. I don't have to go find the information, copy and paste it out into my prompt. I can just upload the JSON file that has it in a really structured way. This JSON file also contains information about primary keys and foreign keys, or the connections between my tables, basically, so that it already has the context of what data is available through those descriptions of the columns, descriptions of the tables, and how it connects. So it knows how to use the connections between the table. So you don't have to explain to it everything. Next, you want to state your question clearly and avoid ambiguous language. Then use structured methods whenever possible to describe this stuff. I already mentioned that. And document any typical query patterns that we take, like we always left join this table to that table, something like that. That's the general idea about step one, but we'll do a lot more detail about it. Step two is about your review of the information. And now we have to do this because we trust but verify. AI is going to be this great tool, but it can misunderstand the context or misunderstand the information. And guess what? Most often, it's the human doesn't give good information for it to get the context. So you have to get better at asking questions, better at delegating. This is positive for you overall anyway. I'm going to give you this outline, sort of prompt review toolkit, and we're going to look at it in detail through the next many slides. And the four pieces of it are starting with verifying that you've got the right tables involved. Next, checking filters. Then evaluate your joins in the SQL statements. And we are going to show in detail what the different joins are, how to think about them, and then look at any groupings and whether or not it's appropriate or it should be grouping. So here it is. Here's the toolkit. There's a lot here because I want it as a reference material you can come back to. So I'm not going to explain to you or read to you everything on here for right now. This is a great tool for you to come back to. We're going to talk about each of the components, though. We're going to talk about the tables. How do we ensure that we've got the right tables involved in the SQL query that gets generated from generative AI? One option is to just do a reasonable prompt here. So you see here an example. I've got Gemini up and it's in my environment. So it knows the area I'm looking at. And I say something like, how many of my patients had x-rays? Really, really crummy prompt. And from there, it's going to make some decision about the table it thinks I am referring to. It might even do a good job. But often you'll still need to adjust. And there's tools for this, right? If you're doing it in Gemini and querying against BigQuery, there's this great opportunity. They put it here for you. Hey, why don't you tell us what tables you need? And so this would be an opportunity to tell it, oh, I'm going to need more than just the orders table. I've got some other information, I've got to figure out here. So that would be option one, is that you can write a crummy prompt and do a manual fix. Option two is just to write a better prompt, right? Go ahead and specify in your prompt what are the tables you have in mind in some structured way. I've written it this way because of how Gemini looks, and so that I could make it viewable for this presentation, but this might take different formats. You can structure it however you want. You can see here, I've gone ahead and listed the tables and included the ones that I want, and then the prompt separate from that. You're going to get to a similar end result, and it's whatever you're kind of comfortable with. I think it's good to get in the pattern of creating a better, more structured prompt as you continue, but however you work. Next, that's tables. That's how we ensure that our prompt or our process has the tables incorporated, that we've specified this is what you should be looking at. Next is filters or scope. This is the who or what did we want included or excluded to make sure it's looking at the right population, it's looking at the right year, it's looking at the right time, whatever the case may be. So I'll give you option one, option two again. Option one, you can write something like I have here, where I tell it the tables and I give it a prompt to say how many of my heart failure patients had x-rays, and let it guess at what the filter might be. So this is an example of a prompt I put in, and it assumed, oh, let's just think that he said heart failure, that must be how it looks in the data set. He said x-ray, that must be what it looks like in the data set. It's wrong. And so I really recommend you get used to doing option number two here, which is a better prompt. You need to go check your data often and see how are these things referenced in the data. And so sometimes this is doing small little queries of the tables to get to learn them. Also, as you get familiar with the tables, this is stuff you learn and you keep, or you might have from past examples. So here you'll see a much better prompt where I've got the tables there, I've got a prompt, but I also have a section where I specify the filters, right? I say filters are DRG name needs to be equal to exactly this, and the order description needs to be equal to exactly this. And so in the query below, you see an actually correct query within our data set here, so that the string it's searching for in that column is accurate. And the only way that's going to happen right each time is that you specify it. So get used to doing option number two on this. Here's another little checklist for what kind of filters should I be thinking about, okay? Time window would be a common one. This year, this last 12 months, something like that. Locations, is there a specific department, specific hospital, something like that. Other care details that you want to filter to, like only of this order type, only this order description, whatever criteria might be meaningful there about care details. And the last one to think about is, do you have any encounter descriptions you want to filter to? Only folks from this particular origin or chief complaint, something like that. So that's just a quick checklist of, hey, do any of these filters apply and do I need to make sure they're in my query? Okay, we're moving on. We're looking at joins. Maybe for some of you, the first time you're thinking about joins in SQL. I've gone over at a high level joins in other videos, but now we're going to look in a lot more detail. So the join is about how tables get put together, And so here you'll see an example of sort of a vague high level prompt, option one again, where I specify the tables and then I ask it a question. And so it's going to make a choice. It's going to say, oh, I'm going to interjoin these two tables together on order CSN is equal to hospital CSN. It joined on the right thing, but it might not have picked the right kind of join. So we're going to look in detail at a tool that I have built into my application at Praxable. So I'll highly recommend you get there. and subscribe so you can come and use resources like this. This hospital data set that I have in BigQuery for you, I've got a tool for you to explore. What would it look like to join these different tables together with the different types of joins? So we'll start with that inner join that we saw in the previous query. We are going to take a left table of hospital encounter and the right table of order detail there, and we'll choose an inner join. Now, in the top right-hand corner, you're seeing sort of a visual representation of what's happening, which is we've got both tables and we are only matching on the overlap of them in that blue color. In the sample record below, you're seeing 7 rows of what would happen between these two tables. So in blue, you've got where there is a match, where we find the CSN on both sides of this table. But the key to be looking out for in an inner join is that it will filter out records wherever there isn't a match on both sides. So the hospital columns are to the left and the order columns are to the right. So you see this example where there is an encounter that's in the hospital table, but there is not a match in the order table. Well, this encounter is now removed from our results. So you want to make sure that that's actually what you would intend to do. And then below that is the opposite is also true. If there are encounters that are in the order table, but they don't have a matching encounter from the hospital, then that will be filtered out of your results. So inner joins can often actually result in filtering, whether or not you actually want that to happen. So that's the what to look out for in these. In the upper left in this tool is where you can select which tables are connected. You'll see a description of what the join is doing over to the right. The blue is going to represent what got matched, and in the record below, you'll see that same thing. Above the tables is a one-to-many relationship. It is telling you that on the left-hand side in hospital encounter, you will only have one record. But on the right-hand side, in order details, there may be more than one order per encounter. And that shows up in our record below. And in this little sample result, you're seeing the indication that these are duplicates. So that is the other item to be thinking about when you're joining. This isn't specific to inner joins, but it is something that really comes as a risk with many joins, depending on are there possibility for multiple matches between these tables? In these two tables, they are. And that should make sense to you because we've talked about a summary record like hospital encounter and a detail record, care detail record like order detail. This is where you're finally seeing an example of what I mean, that the care detail, like order detail, has multiple entries per encounter. And so you can get the result when you join them that there will be duplicative information from the hospital encounter because there are multiple orders. So each record will be unique about the order, but because of that, what the system will do, what SQL will do, is give you back the identical information on that hospital record. So you're going to get duplication of that information. That's something to just understand about how SQL joins and returns information. And this is your first one we're looking at, is the interjoin. But there are 3 others to kind of look at here. I mentioned to you the filter out to be looking for. So let's move on. Now we are taking a look at a left join between these same 2 tables. What would happen if we took the left table of hospital encounter, the right table of order detail, and said, give me a left join? In that scenario, what's going to happen between these 2 tables is all records from the left table will be included, plus any matching records from the right-hand table. You can see that visually represented up here. And below, you can see what those different records are and how they relate to the visual above. The blue records are records that are matched, that we've got hospital detail and order detail that match up, and we're going to get that information. But the left part of this is that we will include all information from the left-hand table. So the green record there is an example where we have hospital records, but no order records. Because we made this a left join, it will return that row. And what you'll get in the order detail for that row is a null. You'll just get no information. So that is a choice that we make whenever we want to keep all the records from the left-hand table, this hospital encounter table, and return, whenever applicable, detail about the other right-hand table, the order detail table. Again, we need to be cognizant always of the relationship that this is one to many and has the potential to duplicate whenever there's more than one result found. And this too can have a filtering effect. However, you're going to see that there's only the filtering in one direction, that we will only filter out detail that is present in the right-hand table, but not present in the left-hand table. So that is just one side of that filtering out problem when you do a left-handed join. Now, a right-handed join should be pretty intuitive because it will include the exact opposite of what we just saw. Everything from the right-hand table and only stuff from the left-hand table if there's a match. So down below, you're going to see that information. In blue is the full matches on both sides. And in orange is the records we will get because there's something on the detail side, even though there's no match on the hospital encounter side. So you'll just get null values in those columns in what is returned. It's a one-to-many relationship, so you can still have duplication, and you can still have filtering, but it's going to go the other direction, that it will filter stuff when there's no record on the right-hand side. That is the right part here of this right join. So we're still thinking about filtering, but it's directional here. All right, let's finally look at the last example. Stick with me. We're on outer join. So this is a full outer join of the data. And now you're seeing that we actually get hospital encounter detail and or order detail. The description is right here that all records from both tables happen. Now this color coding is not quite right because it says that orange is excluded. That's not really true. It should be notated differently. But I think you're seeing in the rest of this that it's represented properly, that we will get a record for everything that matches, plus everything that has hospital and not orders, and everything that has orders and not hospital. So we really do have an opportunity for duplication just like before, but we do not have that opportunity for filtering out. This is a give me everything type of an answer. So those are your 4 different types of joins that we have to think about. What's the right one for our scenario? And the way you have to think about it is exactly like I just showed you. How will this work if I take everything from the left table and only the matches on the right? Is that what I want? Or do I need it only when there's a match between both? And so this is about thinking. You have to think. In the early learning of this, I often was drawing pictures, examples, making fake Excel workbooks for myself just to think about how these got connected. And so there's no magic here. It is doing exactly like I've shown in each of these scenarios. And you have to think through, what do I want? What would be meaningful? What is the table I want returned after this is completed? So your option 2 is a better prompt. Remember, we're still talking about how to evaluate if we got the right joins. And so that's pretty simple. Specify the record level that you want returned. You don't have to say, I need a left join, I need a right join. What you want to do instead is specify that for the record level, I want to return, in the example to the right here, just 1 record per encounter, and make sure that is the case. I'm just kind of being direct about really wanting that. So you see that I add that into my prompt. What record level do I want? That is the key element that's going to drive the right type of join, as well as the right group by type of decision. So grouping is used when we are summarizing and trying to answer a question at some granularity within the data. And the core question is, does this group by help align with the story or the goal of the question that I have of this data? So option one is to just hope that it does well and ask your question. But option two is to specify, where we have, here's the table I need. Here is the record level that I need. Here are the filters that I need. And in my prompt, I ask a clear question. How many of my heart failure patients had an X-ray? So this comes together now to be a prompt template. That prompt template is, when you write a prompt, include the tables that you need, how it should be filtered, what record level should be returned, and then what is our goal or question. An example of that and how it plays out to the scenario we were just looking at could be a structure like this. And you saw it in Gemini where I was just writing it out as a sentence, and I was separating it by hashtags just to give some indication of separation. But it could also be structured in this way. You could write out your prompt exactly like this as a bulleted list. Tables to include are these. The filters will be the following. The record level, I want 1 row per encounter. Join order detail only to check whether the X-ray exists. Return distinct encounters, not rows per order. So that's some of the positive and negative. I want this 1 row per encounter. I don't want, a row per order. So that's being direct about the record level. That should give the context needed to choose the right join by the system. And a final step to ensure that and ensure that our group by is being done properly is a good goal question. My question is, how many CHF encounters or congestive heart failure had at least one chest X-ray? I want a single count of unique encounters. So that is steps 1 and 2, all right? That is the prompt template that's going to get you to generate and review the information. Next is validate and test. We trust but verify. And I've got 2 different directions that we're going to do this for step 3. Number 1, bottoms up, okay? This is single unit checks, gathering a single unit from the relevant levels in your data, like a single encounter, single order, single provider, single day, and looking at, does it look right? This is kind of the basic idea. Or a top-down, kind of a bullshit test, right? Find something that you understand about this subject, or look for a subject matter expert to get a gut check, okay? This is the how many per day, or what percent of the total, to just see, are we in the range? Does this seem reasonable? Those 2 directions, attack it from different angles, help force kind of different questions, and help you do a good job of this. Validation is more about sort of more than just checking the syntax, checking that it's written properly. It's ensuring that the results are actually meaningful to your question, right? That you are returning what you expected to return and can answer what you need to answer. So let's look at both of those with a little more detail. First of all, that bottoms up, looking at the single unit. We can think of this, there's a couple different things in this. Number 1, we're looking for a golden row, like give me just 1 row, 1 encounter, 1 order, 1 lab, whatever it is, and let's just get to where we can see it, manually checking to see that that row looks right. So this is the simple stuff. Run an open query and check the first couple rows. Does that look right? If you have any opportunity to verify it against a truth, like, hey, I can go check the chart and see if it returned the right value, right? I can go look at the hospital chart maybe if I'm in a position to do that. Or, I know a sample patient that I can check to see if I've got the right value. That's the type of thing we're doing for this golden row drill. It's nothing spectacular. Not that complex. We're just trying to get data out to look at it. We're looking for single unique records. Okay, so this is, all right, we thought our data was supposed to be 1 encounter or 1 per order or 1 per lab. Let's go check. Does it appear just once? Okay, this is the kind of check we're doing. And are all the required attributes there that we were expecting? If it's not a single encounter, it might be something like a single order, right? If we went out to the detail to get something more granular, let's verify a few of our encounters to see if they have the orders we would have expected, and if the information that we anticipated is coming up for an example. We can go and look at a single dimension within it, if that's relevant, something like one provider or one patient, all elements of the same thing, a single, right? Single unit, single care detail, or single dimension, or a single point in time. So simple concept that has a pretty practical endpoint. We're just trying to see the record and see if we can spot anything with our own eyes about what's going on here. So that's the single unit check idea. You might take that out to Gemini. You might take that to ChatGPT. So this is not always that you have to write another query. You have to do something. Sometimes it is writing something to understand, writing a good prompt to do this same thing. So here's an example. I want to validate the correctness of the SQL query below using some bottoms-up checks. Here is the final SQL query. Paste it in there so it has the context. Use the following validation structure. Single encounter check, if that's relevant. Single X, Y, Z, right? Tell it, I want you to do this. Single order, single lab, so on and so forth. Single dimension check, isolate something like provider, patient, something like that, or a point in time. Like give me this day, this hour, whatever the case may be that you want to see. Tell it what you want to see. And the final ask is produce a set of small SQL snippets I can run that mirror my exact logic, just on these tiny, one-off opportunities. So it's a prompt you can take and steal from me and use in your validation steps once you get to a query that you think is working. Take it out to one of your generative AI tools and get to some other checking queries so that you can see the information. You're going to just be looking for something like this. You're trying to get to a simple record so you can see the data and evaluate. This seems reasonable. Hey, I'm seeing a lot per encounter here. Is that right? Well, look, there's an order ID on each of these. Yep, this is each one's a unique order. That's the kind of thing that we're trying to get to. Nothing mind-blowing. An alternative is to take your data out to a visualization tool. If you want to do multiple types of checks on the individual record, you don't have to always keep writing SQL, through generative AI. If you get a query result, you can take it out to Tableau, dump it to a CSV, put it in Tableau. Or if you have Tableau connected to Power BI, to BigQuery, then you can just get it out and start looking at it that way. That's a very versatile way so that when you get to your next question, you've got a tool that helps you quickly do that instead of continually writing SQL. Okay, let's go the other direction. Let's talk top-down. How do you do that BS test? The goal is to get some just quick plausibility, okay? We don't need to overwork this one, but you're trying to ask questions of your new query to figure out, can I just figure out if this is the right magnitude? Is it the right amount of, let's say, admissions per day that I expected? Is it 80 or is it 8,000? What would be reasonable? This is the type of checking. Nothing, again, that complex, but just is this in the range? Next, ratios and proportions, if you can. If this is something like number of orders, what proportion of my patients have these orders? Is it changing over time? Something like that, some proportional question just to say, everybody returned with these orders. That doesn't sound right because I didn't expect everyone to. So let me look at what went wrong in my query. Or, you get an answer back like 5 to 10% had these orders. That's far below my expectation. I'm going to need to go back and look at my query. Next would be something like any strange time patterns, right? You could say, does this show up during the weekend, things like that. Or comparison to prior periods. So what would that look like? You might be looking to go out to Tableau and look at your data to answer those questions, or you might be writing, again, a prompt into generative AI to say something like this. I want to perform top-down plausibility and check on this SQL query insert it there, and then use the following types of checks: magnitude bounds, ratios and proportions, temporal shape, period over period. Go ahead and start with this as an outline, but add some detail. Say, I want to do a magnitude check. How many admissions per day? How many orders per week? Speak out some of those needs that you have for magnitude checks in order to get that sense of, is this BS data or not? And then tell it what you need. Produce SQL snippets and reasoning steps to quickly determine. Ask it to help you think through this problem and how you can get comfortable with whether or not it produced good data. So another prompt template you can take and bring it out to your data in order to check. So this is the process that we're in. We prompt, we review, we validate. And the bad news I've got for you, after all that, we are often going right back to the beginning in order to reprompt or change how we ask the question, change the tables we involve, change how we describe the record level in order to get what we really need. It's a very iterative process, and you got to be stubborn and sit there and continue until we complete our goal. So a couple just summary items on that. Include the schema wherever you can. Myself, I just save it as a JSON file. You could probably save that in multiple other ways. I'll find a way to share that through this course, some way that you can download it. So get over to the app, get to praxable.com, and I'll find a way to share that with you in the resources. I've got one built for the BigQuery data set that you guys are using. Treat AI as a helpful companion. This is like an expert consultant, but it doesn't know everything about your business, doesn't know everything about your data, so you have to tell it. Validate the results, top down and bottom up. Maintain some up-to-date documentation so that you're infusing some good schema information. And remember, you're just going to have to iterate and keep working through it until you reach your goal. Awesome. Thanks for staying with me. Lots of attention. I appreciate you taking a look at this approach on using generative AI to get at better SQL for advanced analytics in healthcare. Here's an example just so you can see of what that model.json file looks like for me, and I'll find a way to share this with you through the app, but it is just a structured file that shares where this project is, what the data set is, and then also some table information. You see table name and description, what's in there, and what kind of columns are there. Each column has its own description as well. So this is what gives the generative AI the context it needs to understand the model that we're asking questions of. And you'll see after all the columns and the table description, you're also seeing what makes up the primary key and any foreign keys or how to connect to other information. That actually probably needs to be updated. I haven't gotten that in its properly complete. So this is the type of structured information that really helps generative AI understand how it could ask questions of your data based on what you're giving it.